Welcome to Z-File. Today we're diving into a question that honestly sounds like a riddle. How is it that in a warming world, we keep getting slammed by these absolutely brutal, bone-chilling cold snaps? It doesn't make any sense, right? Well, let's untangle this wild atmospheric puzzle. You know that feeling, right? You wake up, you look outside, and it feels like the entire Arctic just decided to take a vacation and park right on your doorstep. It's this sudden, shocking cold that has you wondering if maybe Queen Elsa from Frozen is in town. So what is really going on way up above our heads to cause these crazy deep freezes? And look, this isn't just you needing an extra sweater. We are talking about massive, continent-spanning winter events. Just think back to that historic cold blast in February 2021. It hit more than 150 million people across the US, with sub-zero temps, snow, ice, the whole deal. This isn't just some local weather blip, it's a huge phenomenon. Okay, so let's introduce the main character in our story. You've definitely heard the name thrown around on the news, but what exactly is the polar vortex? So picture this. It's basically a gigantic spinning pool of super frigid air that hangs out over the poles every winter. And you know what? It's a totally normal, natural part of our atmosphere. But the key word there is normally. When everything's working right, this vortex stays put, keeping all that intensely cold air locked up safe and sound in the Arctic. The thing is, the vortex really has two modes, stable and, well, not so stable. When it's strong, it's like a perfectly balanced spinning top. It's tight, it's circular, and it keeps all that cold air contained right over the pole. For the rest of us, that usually means a milder winter. But when it weakens, it starts to get all wobbly. It gets stretched out, sometimes it even splits apart. And that's when things get messy. The walls of that cold air reservoir just break down, and all that frigid Arctic air comes spilling out to the south. But hold on, the vortex isn't working alone. Nope, it has a partner in crime, an accomplice that actually delivers that cold air right to us. And that's the jet stream. The jet stream is pretty much what it sounds like. It's this super fast-flowing river of wind, way up in the atmosphere that circles the entire planet. Its main job, its entire purpose, is to be a barrier, like a big atmospheric fence that separates the cold polar air in the north from the warmer air down south. Okay, so here's where it all clicks together. When that polar vortex way up high gets weak and wobbly, the fence below it, the jet stream, loses its strength. It slows down, and instead of flowing in a straightish line, it starts to wander in these huge looping waves. And those deep southward dips in the wave, they're basically open gates, letting huge chunks of that freezing Arctic air plunge way down into North America, Europe, and Asia. Right, so we know how the cold gets out, a weak vortex and a wavy jet stream. But the real million-dollar question is, why is the vortex getting so weak in the first place? And this, my friends, is where we get to the central paradox of this whole story. It all kicks off with something that has a wild name, a sudden stratospheric warming, or SSW. And it is as bizarre as it sounds. We're talking about the air in the stratosphere. That's way above where our weather happens, suddenly heating up by as much as 50 degrees Celsius in just a handful of days. This crazy blast of warmth literally just slams into the polar vortex from above. It knocks it completely off balance, causing it to weaken and stretch out. That, in turn, makes the jet stream buckle, and boom, you've got yourself an Arctic outbreak. So why are these strange warming events happening more often? Well, it really all boils down to this one single, staggering number. The Arctic is warming up nearly 4 times faster than the rest of the planet. It's a phenomenon called Arctic amplification, and it's the engine driving this entire chain reaction. The atmospheric scientist Dr. Jennifer Francis explains it perfectly. You see, the jet stream gets its power from the huge temperature difference between the icy Arctic and the warmer south. But as the Arctic heats up, that difference gets smaller. Less of a temperature difference means less fuel for the jet stream's engine. So it slows down, and just like a slow-moving river, its path gets wider and wavy. So here's the big takeaway, the thing you absolutely gotta remember from all this. A warmer planet doesn't mean the end of cold weather. No way. It just means the refrigerator door at the top of the world is getting left open more and more often, letting all that cold air spill out and visit the rest of us. So what does this all actually mean for us, down here on the ground? Well, the impacts are very real. They're global, and they can be incredibly disruptive. And believe me, this is not just theory. During that major event back in early 2021, That wobbling vortex sent Arctic air plunging deep into Texas, causing massive power outages. At the same time, parts of Canada were dealing with life-threatening wind chills of -50 Celsius. Even Athens, Greece got buried in snow. And on a global scale, all that demand for heating made natural gas prices go through the roof. These are the real-world consequences. It really brings us to this pretty mind-bending question, doesn't it? Who would have thought that a whole bunch of heat building up at the top of the world could be the direct cause of a record-breaking deep freeze thousands of miles away? It's completely backwards. And that's really the ultimate lesson here. Our planet's climate is this unbelievably complex, interconnected system. A change in one tiny spot, like some sea ice melting in one part of the Arctic, doesn't just stay there. It can set off a chain reaction, a cascade of events that leads to these massive, totally counterintuitive results on the other side of the globe. It just goes to show you, every little piece matters. And that leaves us with one last kind of unsettling thought to chew on. We are fundamentally changing one of the most important climate regulators on Earth. So, as the Arctic continues to transform at this incredible speed, you just have to ask, what other surprises does winter have waiting for us?